Alrighty, I think we are live. Howdy, folks. So we've got around 47 people in the stream, which is cool. So we're probably still going to have a few people coming in and finding their virtual chairs. Oh, 48 now. So a few housekeeping things before we get into the presentation. There's a Q&A session. There's a Q&A screen on the right-hand side. If you don't see it, just push one of the arrow buttons that will kind of bring that out. In there, you have chat, participants, and Q&A. So if you do have any questions, please do ask them. You can upvote them as well. So I'll be having a look at those towards the end. And there is a raise hand function if you do have any technical issues or anything. But also, if you do have a question and you want to jump in video and audio and ask it, there is a raise hand as well. So we can bring it up to the virtual stage, and you can ask your question. And if you want to go back to the foyer during the presentation, use the link in the general chat. So without further ado, we'll introduce the two speakers we've got coming up. So we've got Mo and we've got Dani. So Mo's from Ledger Ops. So he's run the gamut of cyber security space, from penetration testing for Rapid7 as a consultant, penetration testing numerous federal agencies, testing mobile applications for HP, contributing exploits to the Metasploit framework. Thank you very much for those contributions, Mo. We're definitely going to be using a lot of those. And then we have Dani as well. So he's from NetAlpha Financial Systems. And at age 20, Dani founded his own boutique company for innovative software and hardware solutions. And these two very handsome gentlemen will be talking through their presentation from the cloud to the ground, rather. So I'm actually really interested to hear the technical aspect of these things. So without further ado, I'll hand it over to you guys and let you guys share your screens for the presentation, and away we go.
Cool.
Thank you for having us.
Yeah. All right. So, like we're introduced, I'm Dani, CTO of NetAlpha Financial Systems. This is Mo, co-founder of Ledger Ops. So, quick review of what we're going to talk about today. We came to this idea for this talk. I came from more of a development and cloud architecture and some cloud pen testing background. Mo is more from the internal pen testing, and we wanted to see how we can join forces and get a really nice kill chain from the cloud to the ground. And that's what we're going to present today. We're going to present a few techniques that we saw, both for attacking clouds, also a little bit of blue, a bit of defensive, and then from there we're going to go into the internal through a couple of ways, AD proxy and VPC peering, and just show how we jump from the cloud into the internal, and then we get full ownage. So for people who don't know about the shared responsibility model of the cloud, we have a couple of different ways we can use the cloud. We can use it as infrastructure as a service, which is basically you manage your own virtual machines. You do not touch the physical networks, the servers, the hypervisors, but you do have to manage the virtual networks, the OS, your apps. So there's a lot more things to patch and to look out for. Then we go into the PaaS. That's something, let's say you can use Fargate, which is a Dockerized PaaS. So you just basically get your Docker containers, but you do not touch the OS, you don't touch the networks. And then there is the SaaS, or in the cloud, it's a lot of times it's serverless functions. So you basically just provide the code and the data. So for clouds, a few techniques to get the initial foothold. We always have the exploits and exposed machines, different vulnerabilities in web apps, and was pretty common, still pretty common in cloud, is an SSRF and then grabbing credentials from the metadata server. So AWS actually released the instance metadata server version 2, which mitigates a lot of these SSRF and different other ways to exploit and get the credentials. So if you're not using the version 2, look for that and try to migrate to it. So we're gonna get a initial foothold pretty easily with the pickle bomb, which is a deserialization attack for Python. And we're gonna do this on salary workers. We're gonna get put a new message in a queue, in a Redis queue for an exposed Redis. And when one of the salary workers will grab it, we'll get a shell. So we pushed our message into the queue, and then on the right we can see that we have the cat running, and let's get some data from the metadata server. So we get the user data, which is a startup script. A lot of times people leave keys in there to grab data from other services, sometimes keys for GitHub to grab the latest version of the software it's supposed to run. And we're gonna get some credentials. So first we got the role, which is the EC2 instance role. So, and now we're gonna get a fresh set of credentials, which we can actually grab them and use them from our local machine and basically impersonate that machine with AWS services. This is the small script I wrote to do this attack. It's pretty simple. The second thing we'll go through is service mesh poisoning. So we're going to be using new technologies for old tricks. And like any poisoning trick, here I'm going to focus on HashiCorp console, which is it's a great service mesh and service discovery framework. I've been using it for a while. It has a great community. So service discovery. When we work in a microservice-oriented architecture, our services need to know which services are available, how to contact them, get their IP address, get different versions. So that's what service discovery basically does. We register a service, it goes into this, it's a decentralized, distributed data store, key value store that stores all our services, metadata, some tags. And then we also get a service mesh capability. So we get identity-based authorization, we get L7 traffic management, easy way to do sidecar proxies with TLS encryption. So this is what it looks like from the console. We can see we have 2 console servers, 2 Postgres servers, 1 Sentry, 2 Sentry, and 4 vaults. And we can either query the console agent, like the first line, which is console catalog services, or we can do a did request and do postgres.services console, and we can see we get 2 IPs returned to us. So those are the 2 Postgres services that are running in our network. So let's see how we can do the poisoning. We're going to impersonate a service on a compromised machine. So when we have a machine that runs, let's say, a Python web server service, and it registers it, if the setup does not have proper or very good identity management and access controls, then we can basically register another service. It doesn't check if it's actually a Postgres server running or whatever you're trying to run. So you basically just give it a name, and if the name already exists in console, it'll route some of the traffic to your service as well. So this is a JSON format and an HCL file. HCL is the HashiCorp language. It's pretty easy to use. So we have the ID, we have the name, the port, and then last thing that we can also exploit is the health checks can be arbitrary commands. So this has been bash and user imagination every minute. So we're going to move the file into the console folder and do a hot reload. Another way of doing this, since a lot of services are Docker containers. So there's this tool called Registrator. So it automatically registers and deregisters services for any Docker container. So it basically sits in your Docker as a container in the same host, and it will periodically scan to see if any new containers came up and any other containers came down, and update your service mesh based on that. So this is even riskier. So even if we do have good controls and access controls, Register will still have a token. So if we are able to run a Docker container, it will register it because it has the permission to do it. So what we're going to do is we'll start a new container, call it Postgres, and it'll register as a Postgres service, and some of the traffic will be routed to us. So by utilizing a feature, an authentication feature in Postgres, if we can man in the middle it, we can ask the host, the client, to send us the credentials in plain text, and basically make a hash from it, like the real server would do, and send it to the database. So it's transparent. The database think it's doing a proper authentication, but our man-in-the-middle server is able to request the credentials in plain text from the client, and it will give it to them. So we're going to utilize this by registering a new Postgres service with our proxy in there. So we'll get that running on the right side, which is Python proxy py. And then on the left side, we're just gonna make a few connection attempts to the real, to one of the Postgres servers. So we're using in the host, we're using postgres.service.console. As you can see on the right side, we grab the username, we grab the password, we have the salt, and here's the hashed password with the salt, so we can forward that to the real database and establish a connection. And we just stole credentials, no need to track anything. We have plain text username and password. So after we're already in the cloud, we grab some credentials. How do we stay there? How do we hide and make ourselves persistent and be able to grab a fresh set of credentials? Because even if one of the attacks was detected, usually the first thing to do is to revoke the credentials from the machine. So we need to find a way to get a fresh set of credentials and basically hide in plain sight. So Lambda layers, Lambda functions, there are serverless functions. And what we can do with them is we can get Lambda layers. So Lambda layers basically give us the ability to package a lot of the dependencies we use in different functions and put them in a layer, and then reuse this layer in different functions. So if you have an API or a big database, a big folder with database models that you reuse them, it's pretty common to use Lambda layers. So, and Lambda layers are packaged, depends on if you're using Node.js, Python, Java, they'll basically all be packaged into the libraries. So either like the npm modules, or in Python, the lib folder. And we can override like known libraries. So this is what I'm gonna show. I forked the Python request module, which it's really used. So we can assume that a lot of functions might use that. So I got into the request function and basically added another line to it that will take all the environmental variables and send them to my server every time there's a request. And this is my listener on my server. It will take those environmental variables and give me the access key, the secret key, session token, security token, and also the data that was sent to that Lambda function. And in the Lambda function, once the layer is loaded, just do an import request, regular thing to do, and do a regular GET request. And let's see how that works. So we're going to invoke the Lambda function that's on the right with a curl, and we're going to have our listener on the left. So there we go. We got a fresh set of credentials with the session token. And if we do this again, we'll get another set. Don't try to use it. They're revoked. Yeah, we can get a constant flow of credentials. So I've done it. It was not detected. I will talk about infrastructure as code, which actually helps detect things like this. But a lot of times, what happens is that since there's so many layers, it's pretty easy to add a new version for a layer. So we can pull a layer that exists, see what's in it, take it, basically duplicate it, and make our changes and upload that as the new version of the layer. And when infrastructure as code is not implemented, it's very hard to see those subtle changes. So I'm going to hand this over to Mo now.
You need to unmute yourself there, Mo.
Thank you. So we're going to do a quick AD 101. So Active Directory is used by majority of organizations to manage, their systems and enterprise environments running Windows. And effectively, it's a directory service database, and LDAP is the primary protocol that's used to communicate with Active Directory. The vulnerability that we're actually going to leverage for pivoting from the external to the internal is something that was identified by the fine team over at Preempt. Great research that they do. They've done incredible things in the past couple of years, and hats off to them. They've identified a vulnerability within ADFS, which ADFS, for those who don't know, it's a single sign-on solution created by Microsoft. It's effectively an ADFS proxy host is a host that will allow let's say systems that you want to communicate on the outside, externally, to communicate with systems internally without being connected to them. So it allows those services to communicate without a direct connection to your organization's internal network, which is ideal. This is, good job, Microsoft. Now, the problem here is that ADFS supports Windows integrated authentication, and this, unfortunately, due to this vulnerability that was identified, WIA was not protected correctly, and it allowed protocols to be abused from externally. So effectively, an attacker can launch a brute force attack, and the way this was implemented allowed the attacker to circumvent an extranet's lockout policy. So either it was fail open or fail lock, where all the accounts would be locked out. So you do, some simple reconnaissance. You find out an organization's email, first initial, last name, or first first name, last initial, whatever that policy, that naming convention is, and you now have a list of usernames, and you can start, effectively just running massive dictionary attacks without ever locking, without ever locking the user account, or you're going to lock out all the accounts. But it was one or the other as a result of this, flaw that was identified. So as a result, you're, as an attacker, let's say an organization has an 8-character password policy, doing countless internal pen tests in my career. Even with a strong password policy in place, the best I've seen is, a lot of organizations their people are using elite speak. So elite speak dictionaries are for the win. So we now have our we've compromised an account, and we are able to get in. And we'll share this slide with everyone, because I don't think the video is going to render correctly, but we now have an account and a foothold. So, ADFS proxy in this environment was used for, typically used for SharePoint or Exchange. And, as I mentioned, we basically used it to circumvent the lockout policy. And the end result, Dani basically was able to, before Microsoft released a patch, he implemented a quick fix that would essentially put rate limiting. So
One liner.
One liner there. So we have our foothold. We have our account. Let's say we identify a VPN or Citrix Gateway, whatever that may be. We're logged into and we have access to your internal organization. Let's say we're using VPN and we're logged in. So a quick rundown, a whole bunch of different ways to destroy an organization's internal environment before you finish your coffee. One of the items that I'm going to discuss is, something that I've been constantly battling with throughout my career has just been how much trust is based on what vulnerability scanners are telling people. All the vulnerabilities that we're going to identify that we're leveraging are of the info, low, and medium variety. There's been a lot of talk about PowerShell being dead. It's been resurrected as of late. Empire Project has gotten has been revived. But I like to kind of use the new stuff. So I'm a big fan of using, .NET, install shield. We're going to discuss different undetectable payloads, different C2s and C3s, bypassing NTLM relay mitigations. We don't need shells, but they're way more fun. So hopping in internally, just a quick scan. And we're just going to do a quick enumeration for null sessions. Null sessions are great because this allows us to basically enumerate AD. In this case, we have credentials, so we can actually enumerate what's in Active Directory. We're going to look for SMB signing disabled. SMB signing disabled is allows us to perform relay attacks. It's only been around for about 12 years or so, but they're typically categorized as medium findings, but they're highly effective because when you do exploit a system using relay attacks, you do have system privileges. We're going to look for anonymous shares. Anonymous shares are, besides the obvious of accessing what's on the share, you can also upload malicious SCF files, which then you can combine with Responder to obtain net NTLM hashes of users who just automatically, every time they go to that share, they're automatically going to authenticate to you. And as a result, you'll get their net NTLM hash, which then you can actually crack. And our scan is going to look for effectively those items and for, system that is listening on LDAP, which is going to, tell us, okay, here's a domain controller majority of the time. So quick rundown of SMB relay attack. And, this is kind of like the quick 101s. And we're going to get into a little bit more of the juicier stuff later. But just a quick diagram, because everybody loves diagram. And we're going to, enable WPAT spoofing and relay authentication requests that when you couple with responder or MITM6, you can basically relay, let's say user A attempts to authenticate to user B, or they were to attempt to access a website on your internal, then what you're effectively getting is their authentication attempt is going to be relayed to a list of targets that have SMB signing disabled. And that's what I'm going to be doing in that attack is I'm going to be, authenticating to every system that has SMB signing disabled. And the moment that that system, that user has admin privileges on any of those boxes, then I'm going to run secret stump and, look for clear text, grab their hashes, all the good stuff. So, you may ask yourself, what if mitigation such as SMB signing is enabled or they have EPA? Well, there's a vulnerability in that as well. So 2019-1040 allows you to bypass message integrity controls and NTLM authentication. So if you to fire up NTLM Relay X and use a remove MIC flag, that'll allow you to exploit that particular vulnerability. So, even if the system has SMB signing enabled, you're still going to compromise that system, assuming that patch isn't installed. So as I mentioned, the remote code execution results with system privileges, which is, everything. And, your typical post-exploitation routine, which we really won't cover because that's a whole nother talk, will allow you to get to, domain admin privileges. If you were to couple this attack with a priv exchange attack, you'll have instant domain admin. So another cool attack vector that was identified by Dirk John. He's an exceptional security researcher. Hats off to Dirk. He was able to identify, a part of this vulnerability was that, you can take any type of NTLM authentication, and typically in a normal, in what, the way that it's designed is you're not supposed to be able to modify, cross-protocol authentication, but the vulnerability that he identified would allow you to relay, let's say, SMB to LDAP. So a couple of bugs resulted as a result of that, and even patches that were implemented by Microsoft were found to be flawed. And the team at Preempt also found 2 to 3 different additional vulnerabilities as a result of those patches being released. So definitely look into that. It's very, very interesting. And so, another attack scenario that we're going to look at would be to get hosts to authenticate to us in order to relay their authentication attempts. So using any Active Directory account, you could just effectively connect via SMB to an Exchange server, and you trigger a spool service bug. For Exchange server, will connects back to us via SMB, and then we relay that authentication attempt to LDAP, and we're using relayed authentication to grant VC sync, and we're dumping all the hashes. So, this also works in Kerberos as well. You're relaying LDAP over TLS to create a machine account, and you're running the printer bugs against another domain controller, and that results in relayed connections creating a computer account, which then we can use to impersonate a DA account. We can also pillage AD, and using that impersonated ticket, we're going to run secret stump against the domain controller. So that's another attack vector. So you're going to ask yourself, okay, what if we're testing an organization that has, LMNR, MBT, MDNS, protection from layer 2 attacks? Well, and they even have, let's say, SMB signing enabled with the latest patches, well, then we're going to go after IPv6. So MITM6 is a tool that's released by Foxit, and it can be used to perform the same type of relay attack. And the best part is that it's going after DNS6, which a lot of organizations aren't really even monitoring IPv6. Even to this day, they're still not monitoring, and a lot of products aren't monitoring IPv6. So you're effectively, gaining the same type of attack vector as a responder attack would, and it goes noticed in a lot of organizations. So one of the attack vectors right here you'll see is how we can leverage MITM6 to pop a domain controller, and then you run secrets dump, one of my favorite tools. Thank you, in Packet. And this is a new vulnerability that was released 4 days ago. So known as zero login. So you get instant domain access by subverting net login cryptography. So effectively, the vulnerability lies in net login sets the initialization vector to a fixed value of 16 bits. So we can actually typically in around 256 iterations are able to identify the value that we need to impersonate any computer, including the domain controller, and then we're executing and remoting RPC calls on their behalf. So once we do that, we're going to change the machine account on that domain controller to password that's null, and then we run DC sync plus secret dumps, and now we just pop the DC. And this is this is very, very critical. I wouldn't recommend doing this on a pen test as of right now, because it does cause the DC to go offline as a result of the password being changed, and it's not able to communicate with other DCs. Now, there is a new POC out that does revert the password of the DC back. So that's helpful, but since this is only 4 or 5 days old, it's I would keep this in your back pocket unless you're testing an environment that's very, very redundant. So moving on, this is kind of one of my little weapons of mass destruction that I like to call it, where I would fire off, and these are smash and grab pen tests. These are not, month-long red teaming engagements or 2-month-long red teaming engagements. So here we're coupling responder with MITM6 with NTLM Relay X. We're pointing it at a list of hosts that have SMB sign disabled, and we're going to, the moment that we have code execution, we're going to launch instructions to the systems that to pull our stager, which is very dangerous. This is me on a pen test. So here we're spinning up our listeners, and we're using HTTPS listener, and we're going to use MS build as our stager. The reason why I'm doing MS build is because it allows us to effectively do an in-memory compilation of our payload, and then it's executed, so nothing touches disk. And in fact, it wasn't until recently that Microsoft started actually using AMC to look for these types of attacks. And there's a lot of different AMC bypasses, but we're generating a builder for using MS build. And what you'll see here in our attack scenario is we've got NTLM Relay 6, NTLM Relay X running V6 coupled with MITM6 and responder, and we're effectively instructing a system to use MS build to connect to this SMB shared and grab our stager, and then compile and execute it. And as you can see, we're attacking, every single target on our internal network that has SMB signing disabled. And the moment a user has admin privileges, they're going to download our stager, compile it, and execute it, and we're getting shells with system privileges. And as you can see from the timestamps here, this is, on this internal pen test, I was able to pull up 50, 60 shells within 3 seconds. It was an absolute bloodbath. So it's a great success. So once we get our shells, I'm a big fan of Silent Trinity. Shout out to Bytebleeder. Great tools that he produces. Crack Map Exec is another one of my great tools. One of his great tools that I love to use on my tests. But over here we've got a AMC bypass, and what we're effectively doing is we're suspending Defender momentarily, so that way we can run Mimikatz and obtain clear text credentials. And then, and you can see in the screenshot, we're running on a 2012 server. And then once we obtain the credentials, we're going to enable the AMC service. So highly, highly effective. And you're making Mimikatz great again. There's alternative methods as well. Donut, you can, use LSASI, proc dump, anything really, but just one of the quick, fun, easy ways of doing it.
You mean the sound? Yes, but Arabian Jews have not made sound for thousands of years. Now it's time, my friend.
So, Dani, I make the sound.
All right, so we have 2 minutes left. I'm gonna do as much as I can from the defensive side, and we will post the slides. So yeah, I encourage you to check them out. So first thing, infrastructure as code, either HashiCorp, Terraform, or AWS CloudFormation. Terraform's on the left, CloudFormation on the right. The biggest advantage that I see from that is, especially if you do daily scans or daily updates, you can see when things change. If they're not in code and they changed, either someone changed it manually, a developer, which he shouldn't be able to do in terms of permissions, but it's great. Immutable infrastructure, HashiCorp Packer can bake AMIs and not start patching things. So you make a new AMI every time a new update or patch comes out, and you deploy it across your infrastructure. Duplicating your CloudTrail buckets to another account with a one-way sync. Great Medium article that shows how to do this. Even if someone gets root access to your account, he won't be able to delete it because it has a write-only permission to write it to a bucket in a different account. Secret management, highly encouraged to use it. Don't hard code, don't put things in environmental variables. I use HashiCorp Vault, but AWS SSM parameter store is also great for that. I like HashiCorp Vault because it does generate short-lived DB credentials. And I think we're out of time. So check out this list of open source tools. Highly recommend using them. And those 2 AWS services. And if we have time for questions, we can take questions.
Right, I think we're out of time because we're kind of running a couple of minutes behind. But we'll be taking a 2-minute break between sessions. But if you do have any questions, if Dani and Mo, if you maybe want to jump on the table, and then people can find you and ask you any questions directly within the 2-minute break. Or if you guys are around for the rest of the day, that'll be great as well if you want to take any questions or talk through. There was a question around the slides, which you answered, Dani, so that's fantastic. I think a lot of people are very interested in having a look at those. And I think that was pretty much it for the questions anyway. If you do have any these guys will hopefully be around for the next little bit. So thank you very much. I quite enjoyed it, and the more Zohan references, the better, in my opinion, in any presentation. So it's very, very cool research and very, very cool hacking as well. It's always really nice to see, and I definitely appreciate live hacking and the live demo, because it never goes well. So thank you very much.
Thank you for having